I solved the last question. Not the last question, the question before last lesson. Do you know they have many switches, they have delay,
Yeah.
and they ask you whether there exists the maximum necessary number of n.
Mm-hmm.
I can tell you this question is similar to the question we do you know the pinhole camera?
Yeah, that one.
Yeah, that's very similar. So I think this question was designed by the same guy in Oxford University. So he's trying to use this how to say, this is very unusual way to solve the problem. But that is very practically useful. Okay.
Yeah.
So what I show you, probably first I will I will tell you this this idea. One moment. Did I just got this? And do you remember that question? What is question? So question is that we have many switches, right? And the no one, they got just one L. You see, they got L. Other got the different number of L. You see, different number of L. Just draw one of them. So this is I. This L. So it's a delay. The switch of delay. There are many of them, right?
Mm-hmm.
And eventually you got the signal. So they got a total delay is. So it says the interval of delay is that delta L equal to L maximum. Take the L minimum delay. Do you remember that formula?
Yeah.
Okay. So we know that if every time we use this L, so if we assume there are this number of switches, so therefore the minimum, that is the question is, minimum delay is equal to n multiply the L, you see, the shortest for each switch, while the maximum delay is equal to n multiply this delta L. So delta L is not, they're just trying to make sure the change each time, each step is not too big, okay?
Yeah.
Okay. So these are the two basic formulas. This is third formula. So this first formula. This second, this third one. And we have solved that one. So we just, delta L is different between these two. So therefore we can factorize this in. Do you remember this formula?
No.
Huh? Can you imagine that? So we just combine, so we just use,
yeah.
we just use equation 3, take 2 and factorize n, can we? Okay.
Yeah.
So in this way, n, the number of switches or number of steps can be written as this form. Okay. Of course, we know in this question, we know that delta L is larger than L. Otherwise, there's no point, right?
Yeah.
We can make delta L is larger than L, but not too big, right? Not too big. So therefore, we know these two numbers are different. Now, they ask you, they found the n. So what the question is, what is n? Which is maximum, optimize. In this case, they wouldn't ask you just for optimize. This says what is the maximum, all right? But for the maximum necessary, you ask me these questions twice, right? What does it mean maximum necessary, right?
The number of switches used.
That's right, yes. Not too many, not too small.
In order to achieve what?
Well, in order to find this number, is there any minimum or optimize, I should say, because they are looking for maximum for the necessary numbers. So therefore, actually, they are talking about optimized numbers.
Yeah, is the L resistant or something?
No, L is delay. L is delay time.
Yeah.
So when you study in electronics, you can put some device you don't know you have studied. So you just this black box, all right? It's not a resistance. You just delay, time will delay. So this goes this will slow down a little bit. That is just called the delay. Okay. So air for delay, all right? Both of them is delay. Time delay.
It is asking to find the maximum
N
and
necessary.
to achieve a maximum delay.
Oh, sorry, minimum. So minimum N. Is this if do you want to read the story? You want to read the? Do you want to see the question?
No, I know what the question is asking.
Yes,
I'm just wondering if it's asking for the minimum number of delays used to what are they trying to achieve?
Well, they have the objective delta L. So delta L is objective. They will achieve this range.
Yeah.
So the delay must be adjustable between the maximum and minimum.
Okay.
And they don't want to. You see, if you are a manufacturer, you don't want to. You don't want to use too many switches where the cost increase. Okay. For example, if 10 switches can achieve this objective, why should you provide 550, for example? Yeah. Okay. So it's very practical problem. But how can we solve this problem? That is the issue. I think last time I almost got this idea, but after that, I just use a graphic. I don't have this graphic. Can you rewrite this question as our function? You see?
Yeah.
So can we use Z to represent N? All right. And this is L. Can we use X, Y to represent these two numbers? Can we? Can you follow me?
Yeah.
So in other words, we use Z. We just use because that's more familiar. So N represented by when the delta L is represented by X, and L is represented by Y. 3 variables. You see, yeah. They are all variables. So that's why I noticed that in this test, they're looking for students' analytical skill. Okay, given a relation, how can we apply this formula to solve the problem? Now, question, can we draw this graph? You know how to draw this graph?
No. But it has 3 variables though.
Well, you see, if you can fix one, if we just fix one, what can we do? So you can draw two diagrams. Okay, one is, can we see? Can we just fix this delta L first? Can we draw this diagram? If this is Y, how can we draw this diagram?
Reciprocal.
Reciprocal, and also they have negative sign here. Be careful.
Negative.
Can we just assume this? Can we assume this negative delta? Can we? Non-zero. So what would happen at this value? Good. Which part? No, your is 0. Okay, your is negative. Your function is this one. You are doing this one. You see.
Oh, so it's. Oh.
Now that infinity will happen at here. Can you see? When Y approach to delta, they get infinity. Can you see? Z will become positive infinity, right? Because when Y decrease, depending on Y is decrease or increase, if Y is smaller than this Y, then that will become positive infinity. Can you see?
Mm-hmm.
Can you draw that diagram? That's good for you. This is a mathematical problem now.
And when Y approaches 0,
yeah.
Oh, it tells nothing.
How about Y equal to 0?
Changing L over.
So that is, can we say delta L, delta over delta L, do you agree? Okay. Positive, right? And then when Y equals, it's still positive, right? If the Y is less than this one, Y is 0. But everything is increase or decrease.
Do you mean increase or decrease is positive?
You can try. So if that origin is this height, and the denominator getting smaller and smaller, can you see the denominator getting smaller and smaller when y approach to delta L? Can you see?
Yeah.
Decrease.
So that Z will increase.
Yep, as a whole, zeta will increase. Yes.
When I've drawn here.
Yeah. Can you do it continuously?
I only have 1 point.
No, there's 2 points. This is infinity. You cannot do that as well. This is infinity.
Like this?
Yes. Haha. That's right.
Okay.
That's right. Okay. Now, on the other hand, so you can use another one. Can we also draw this one when delta L is we replace by x. X is variable. Can you see?
Yeah.
So we know that L is much smaller than delta L. Can we put the L here? Now, can you draw this? Can we use different color to draw this diagram? This one.
When x approaches.
When x from 0 approach to L.
So L, it becomes infinity.
Yeah.
And when x approaches 0, it becomes negative.
Yeah.
Negative.
How about so x? You can start from 0, right? At the beginning is negative, right? Mm-hmm. Positive,
like
negative, positive, negative, negative, negative. Positive. Are you sure?
Yeah.
X is smaller than L. L is positive. Can you see?
When x equals 0, it becomes negative L.
Yes, it's negative.
Yeah.
But it's always negative, right? Yes, this is some mathematical knowledge now. Think about it. If x getting smaller, f getting larger.
Oh, yeah. And that this one is larger than this one.
Yes. Can you redraw that? Can you redraw that? I think the scale is one of the. You are right. Y-intercept, or this is zeta intercept. The vertical interception is still negative. Do you agree? Because this is the same. Can you see? This would be big areas, even larger. Can you redraw this one? That's be interesting diagram. Can we just extend, because L is smaller, isn't it? L is smaller, therefore this distance. Can you follow me? This distance is down here. Can you see? That is the delta L, negative L. Do you agree? Because we agree.
Say that x, when x equals small delta L, and so that x can be like smaller than y according to this equation.
Oh yes.
Yeah, so that it will always.
Yeah, in that case, we will consider other side, right? You're right. Yes. So x always start from so x is yeah, you are right. Yeah, we don't have to consider this part. You are right. We don't have to consider the range. We must consider this range. Okay. So these are you follow this domain, right? This x domain.
Yes.
That makes sense.
Yeah. And when let x approaches small delta L, it will become.
So what would be x equal to L?
It's here.
Positive or negative? Yes, it's higher.
Zero.
No,
Zero.
Infinity, right? Infinity.
Yeah.
Infinity. So yes, can you use your color? So it will be here. Can you see?
Yeah.
What happened? Can you continue to draw this diagram?
I need to find another intercept. Like when x equals to delta L.
No, when x increase, can you draw this diagram? We know x is not. You are right. We know x is larger than L. So can we draw this case? How about can we draw the x larger than L, but smaller than delta L, capital delta L? Yes. Wow. Can you solve this problem now?
Intersection.
Yes. Which one? Where is the intersection?
Yeah.
Yes. So this is graphical method. Can you see? So this is our n we are looking for. So this is n. Can you see this particular n? If you go there, can you follow me? Because
how do you find interception?
Yeah, you need, of course, you need to know these two value. I think in the question they provided these two value, right? Small l and delta L. Can you understand?
Yeah, but I don't know how to find interception.
Well, you have subsequent you have to use the two formula. Can you see?
Yeah, you let them equal to each other.
Yeah, that's right. So basically, if you don't have use y, you don't have use y. If I go to next page, so basically you can use the original notation, knowing it's a variable. Okay, so you can use two formula. You can use delta L, and that is one is delta x minus x. Okay, another formula is delta L x. You can use x now. Can you see? You can use L. So therefore, there are two functions. Can you see? That's dependent.
There isn't one. Why?
Sorry?
Are they both or what? Why?
Well, there are two functions anyway. So this you can call it a y n1 n2, but their dependence are different. You can, that's why I prefer to call this y. Okay, you have just like two functions.
Yeah, but when you let them equal to each other, doesn't that confuse?
Well, you are solving. So you how do we how to find the interception? Tell me.
You let them equal.
Yeah, you need n1 equal to n2. Okay.
Yeah, but this two x, the x don't equal. It's not equal.
X
this one L is equal to L small l. This one L x is equal to.
Think about it. I can say if you just think about it. Okay. How do we solve x?
But there are two variables though.
How? Well, that is given. And let's just check the original question. All right, they give you. So these two number must give.
The original equation I already have. Original equation is this one.
Yeah.
Minus L, right?
Yes.
And right. In N1, you let this one equals to X, and in N2, you let this one equals to.
That's right. That's right.
Yeah. How
because their dependence are different, you see. But you have, when you see the formula in physics, you have to imagine that every constant, every position can be adjusted. All right. It's strange. If you see this formula, right? If you see this formula, you can, many textbooks tell you that this G is constant, but you don't have to. G could be a variable, can you see?
Okay.
So whatever formula you see, every element inside the formula can be treated as a variable.
Yeah.
That's something. If you just know how to use the formula to solve the problem, you cannot solve this type of question. Let's just go to the go to one moment. Let's go to the let's share the screen. We see the original question. Where is that?
Also, in this case, you're letting x equals to a constant.
We treat x is unknown. This is x must be satisfied both conditions. That is called interception. That is exception. Wait one moment. I found that website. Think about it. It's a tip. This is a similar to the another pinhole camera question. Let's show you this, the last question. Yeah, you are not very convincing. It's tricky. Okay, can you see? That is a question. Okay. Yeah, they didn't tell you. Well, if they didn't tell you, If no number given, I tell you what, you have to find the formula, that's all. You just treat this delta L and small l as a constant in each formula. Can we return to that? Do you know what I mean?
Yeah.
So can you solve this question? Can you solve the question now by consider we are looking for the interception?
Like when the delta L and L are constants, then the big delta L should be constant. Then why would there be a minimum? And
no. You. Why don't you try it? Why did you negative equal to try if you solve x?
I know how to do it, but I'm just not convinced
why
to do it.
Why do you have to convince you? You just, if you can solve for x, then the problem is solved. You see.
I don't get why you make this one into x and that one into x, but they are not equal.
It takes a while. It's completely different from the eta test, correct?
Because this one equals to L and this one equals to
no. You have to think differently. Okay, you can treat this as two formula. Okay, as I say, this called multivariable formula. Can you see? So in this case, you got two variable, one called delta L, another called L. This is called the multiple variable function. See, they have plane here. Can you see? You have basically you got the curvature. They have curvature here. Can you see in general? But in this case, you will see that there's an interception. Yes.
So x here is just a constant.
No, x is unknown.
Okay, I'll just try to solve that.
X must have value. Yes, X represent a different value. No, are you sure it's delta X? But definitely delta X is a difference between maximum and minimum. Delta L is equal to minimum. Oh, that's better. Yes. Okay. That's it. Okay. So that is X value. Okay. We have two formula here. Can you work out the N by using either of this equation, 1 or 2? So this is a solution for interception.
So is this 3-dimensional?
Oh, we got three variable. We got three variable in one equation.
Oh, so that's 3-dimensional.
Oh,
okay.
So if you treat the constant in the formula as constant, then you cannot solve the problem. Okay. So this is one formula. Can you use another formula to see if these two formula are identical? Different?
Not different, the same.
Are the same?
Yeah, the same. Or not. Wait, I'll simplify it. I can't write it anymore.
You can certainly find some space. Can we clear up this one?
Okay, I found some.
Yep.
Not the same.
Not the same?
Did I do it wrong?
That's strange.
Should be.
Should be the same because we just have two functions. Think about it. Can we just go to some numerical? Can you see? If I just put some number, probably easy to do this deviation. Can we just write y equal to a delta L just 1, and this delta L just a larger one can equal to 10 minus x. Another is function is y equal to and x minus say 2. Can you try again this time without use too many notation? If this two, one moment. I wonder how can they not? It's just algebra, isn't it? Just algebra. Okay, can we find the x and to see if the y is the same? We started from the equal to, okay? So how can the solution give us different? Oh, no, please. Oh, you want to use the original form. Okay, fine. Okay.
I'll use yours.
Make sure your algebra is good enough. Identical?
Yeah.
Yeah. So that's why probably too many notation and get things complicated now, right?
Yeah.
Yes. So you can yeah, well, that is a solution anyway. So in other words, because you see, if you return to that question, you're not happy, huh? You're not convincing, at least, right?
Yeah.
You think the question is still unsolved.
I can understand the last page, but not.
Yeah, the chemical is L. This is delta L. So you see, forget about the forget about the which is constant or not. Can we just just change the L? Yes, that's right. Okay, so we are looking for this point. Can you see this one? So this n is not 0, but it's a minimum, because if you choose other n, you will end up with wasting a lot. Can you see?
Yeah.
In other words, can you see this would be the number of for the one switch. There's another one. Can you see?
Yeah.
So it is a combination of these two variables. The difference.
I understand that to find the intersection is to find let the two functions equal to each other.
Yeah. So this is a problem very impractical. You can see, in the practice, we seem to have two variables, but actually we don't. We have one variable, which is a difference between these two delta. One is L, one is delta L.
Because in the last page, this is how you've written it. Is it?
Yes, I think so. Yes, the only thing I use is I replace it by numbers.
Yeah,
these two numbers are different. One is larger, another is small. Can you see? These two equations is consistent with their requirement. Do you agree? One number is small, a large number is larger. You see? In other words, in this case, delta L is equal to 10.
Yeah.
L equal to 2, that's all. And the delta L equal to 1. So the mathematical form is the same, except the number.
Okay.
This is something new. I realize. Okay, if you probably you will encounter this type of question, but maybe different in different contexts. Okay, they are very smart. Yeah, probably they were asking this type of question, but using different example. Anyway, so what is your objective today? You want to go to the formula now?
Yeah.
Okay. So do you want me to give you a summary, or you have the formula already? Do you have formula?
I do, but like it's not very complete because it only has like.
I think I prepared the formula before. Do you want to see that formula? At the beginning, do you remember? I prepare some formula for you. Do you want to start from there, or you want to from scratch?
Sure.
If I go there, if I share the screen, one moment. PC. It is paper. Did I put it? So much. Yeah, this one. You remember I sent this to you at the beginning?
I can't see your screen.
I have to try again.
The screen is still on the PAT.
Yes. Just try again. Can you see now?
Yeah.
Oh, good. Do you remember I sent this to you? Do you want to start from here or?
Sure. Yeah, the Soviet equation, I never remembered it.
Yes. Perhaps I just go through these contents. I give you a summary, okay, frequency.
Okay.
And Snell's law and standing wave.
Is it from the syllabus?
Yeah, that's syllable.
I think that's all of them. That would be.
Yeah. And the wave function. But after that, probably we will come up with something new, okay? Did it ask you where is a wave? Where's the wave part? Oh, this is wave. They only discuss, they didn't talk about interference, all right? Oh, this one, they use this interference one, can you see?
Okay.
And, but this, they didn't specify this, whether this is for the double slit or single slit, right? So we can, these are all formula, I think. Focus now. This one also, they got omega, right? I give you summary, okay? I know what is the context now.
Okay.
I'll give you the summary. Okay, momentum. Yep. Stop here, go to next page. Right, Paul. I didn't spend much time to work out the force, right? But I still think the first formula is Newton's second law, right?
Yeah.
Because Newton's second law can help to solve a number of questions. So in general, this is a vector form, but in practice, we always reduce into different components. For example, in the x, among the x direction, did the teacher write this form?
No.
So if you have if you want to apply Newton's law, we can either use we use the components form.
Yeah.
Okay. So, for example, when we study the that is something we need to apply. One is project motion.
Yeah, I learned that.
Yeah, project motion. That we're going to use this type of form. So the project motion. It's called Newton's law. That's Newton's law. Oops, sorry. Second law. So the projectile, that is two-dimensional motion.
Yeah.
There's one question, right? Do you remember? They have two steps. So if you start project motion, and if you put the cannon, the starting point at the 0, then the formula become very simple. So that is do you remember? This is initial velocity, and therefore the project motion will actually this diagram or something like that. Okay, so this is y-axis. So if you apply Newton's law here, because in this case the force is always downward, the gravity is downward. You see.
Mm-hmm.
So therefore, you can see in this case, if you apply Newton's law and this force, so therefore there's no acceleration. Okay, I jump to the formula. All right.
Okay.
So the formula just tell you the x as a function of time can be written as ux multiplied the time, because there's acceleration is 0, no force. But the y components, we only need to. Let's see, this is an important formula for projectile motion. Now this case we have to, because this is positive, so this g is negative, right? G is equal to negative because downward, right? This is 9.8. Sorry, acceleration negative. I just read the formula. Can you see negative sign here? So next sign means that this g is opposite of with y direction. Can you follow me?
Yes.
So this formula is applied for any position. Can you see? It's very useful. So for example, this point P, right? So this formula is applied to any position. Okay. When the object landed here, and if this distance is r, this is called range, right? Can you see that?
Yeah.
So in this particular case, the two formula can be written as x is r. Can you see? In this case, y is 0.
Yeah.
So that is how we work. We apply this formula to dealing with project motion. Right. And it doesn't matter which, if the landing site is other position, you can also work out, you can also use this equation. Can you see? Can you see PQR? So no matter whether the object is flying, once we know this the coordinate, we should be able to work out this. We should be able to build the equation to solve the problem. Okay. Now, of course, in this case, they will give you that is the angle is theta here. So that is another additional formula is that the x components ux is equal to u multiply cosine theta, right? And uy is this just like the projection of a vector sine theta. So this is a summary of project motion. Of course, we didn't. What we didn't say is that the acceleration in this case, acceleration x components equal to 0, and the acceleration y components is equal to negative g. Can you see that?
Yeah.
Okay. So that's a project motion. That is so in this case, the force is downward. Okay.
Yeah, I think there's more equation that we used at school. It's like
which
v
one?
equals u squared plus 2as or something. The soup.
That is a straight line motion. You are talking about kinematics formula, right?
No, that's also we used.
Projectile motion, sorry.
Yeah. That is also for projectile.
Which one? Which formula? Can you write it down?
Okay, I'll try.
If I miss anything, you need to let me know.
Okay.
But to use this so simple formula, you have to always choose the origin at the starting point. Okay. You can write the formula. I will see if anything we can derive from these basic formulas.
Yeah, I think it's derivable.
You mean the range? Formula for the range?
No, there's in total 4 formulas for that.
Displacement, right?
I think it's also on the syllabus, on the PIT syllabus. I just saw it. Wait, I'll try to find it.
If you write something, I can see it.
Yeah. Trying to find my formula sheet. Okay, I got it. V equals U plus AT.
You can write down, I can see.
Okay.
V equal to U plus AT, right?
AT, yeah.
Oh, yeah, of course.
And S equals, that's the Y component.
Can you write down?
Okay.
Which formula we're missing? You don't have to remember formula more than necessary, all right? Other, you can use algebra to derive it, okay?
That's the one you've written. And
oh yes, that is a basic formula for the yes. In that case, if you want to find the velocity, can you see? Can we just starting from here, right? Because acceleration is constant, I probably give you more derived formula. So in other words, the velocity x component is always equal to the initial velocity multiply, that's pi 0, right? X component is simple, always the same.
Yeah.
This is for the this general formula for A is not equal to 0. But in projectile motion, these X components, the acceleration equal to 0. And similarly, Vy, you can work out the 2 components of Ay. Then we use this formula, can you see? Here we use this formula. That is a Uy, can you see? Minus GT. Is this formula you are talking about, right?
Yeah.
Yes, trust me. If you just know, if you can just know these 2 formulas, that's enough to describe any scenario in a projectile motion.
Okay.
Okay. Of course, when we derive these 2 formulas, we already use these 2 formulas at the beginning. Can you see? When we derive, we certainly will use this formula. Can you see?
Yeah, this is the same as this one. As the YT one.
But be careful, A is negative now. Can you see? That is the only thing you need to know. Because if you choose a proper coordinate, that A can either be positive or negative. Interesting, they didn't study the inclined motion, right? In this test.
Yeah, but is there any formulas for inclined motion? No,
well,
right.
you need to just find, you just have how to apply the law projection properly.
Yeah.
Do you want to apply the projectile motion, inclined motion as well? No?
No, I think, yeah. What about the third one, the V square one?
Oh, you don't have to. I tell you, algebraically, this third one is derived by these 2 formula by eliminate T. So the third one you don't have to use.
Okay, so they're just used from.
Yeah, like, of course, it's economical if you want to just jump to the conclusion. But algebraically, you can try. You can eliminate the T to obtain the second one.
Okay.
But another thing probably is energy conservation law. Okay, so this formula is the same as energy conservation law. Or should I put it here? They called work energy relation. This is very useful in many, not just in mechanics, but also in electrodynamics, electricity, electromagnetism. So work done is equal to change of energy.
Yeah.
Okay. So these work theorem, this is called the theorem. They have different. This is called the theorem. They have different form. So one form. Oh, one moment. Theorem. So one form is that in the particular case that that in the special case is work done. You can say F multiply the displacement, all right? And that is equal to, or you can cosine theta, that's equal to the change in the kinetic energy in the special case, right? And another one is called impulse. Impulse, this is parallel. It's called impulse momentum theorem. Impulse, sorry.
Is impulse the same as momentum?
Yeah, momentum. Sorry?
Is impulse and momentum the same thing?
No. Impulse is by I. Momentum is P, is different.
Yeah, but that is one I.
Well, impulse is similar to the work. Can you see? It is a product of the force of something, but this time is delta T. Can you see this formula?
Yeah, equals mv.
Yeah, this could delta change. So it's change in the P. Okay. And then when you got a conservation law, so if that work is equal to 0, you got a conservation law, energy conservation law. So that is how to derive the conservation law. Similarly, if the external impulse is equal to 0, you got a conservation law of momentum, which is useful when you're dealing with collision. So that implies that the total energy of initial is equal to the total energy of final. And this means that the total momentum initial is equal to final. You have put your sigma. The product has more than one component. So this is a very useful formula. So these all come from Newton's second law, right?
Yeah.
I can think that is for mechanics. So this is a work. So this is a work. And it's called impulse. Oh, we don't have to write that. We know this impulse. Now, probably some diagram is also useful for you to remember the formula, right? In the case of work, the area under the force distance diagram. So this is F. If this is F, this is distance, and if that is it could be a straight line, could be a curve, right? Could be a curve. So that area were equal to work done. Can you see?
Mm-hmm.
On the other hand, if you have force time diagram,
impulse.
That area, so that's this one, that were equal to the impulse, that area. That two diagram is useful graphically to solve the problem. Let's check if any other. Probably we're talking about the wave. Can you see? Mechanical wave, just wave, probably wave formula. Of course, the basic formula is you have to, the basic formula is this: velocity is equal to the lambda multiplied frequency. Okay. Also, it equal to lambda divide. I prefer this formula, last one, because it's easy to remember. That is wave velocity. Okay. And well, we started from standing wave. Standing wave is if these two end is fixed. Okay, if two end is fixed, it could be the pipe. Okay, the two end is closed. If this distance is L, and then the fundamental frequency. So can we call this this is the L? This is so there's a simple relation between the L and the fundamental frequency.
Yeah.
It's half, right?
Yeah.
And this n equal to 1 is n equal to 2. If you go to higher frequency next to the fundamental, can you draw? With this time with 3 nodes. The first one, we got 2 nodes at the 2 ends. Can we add the one at the middle? Can you draw the standing wave form?
I just left the term and then went to the formula sheet, but when I went back, I can't annotate anymore.
Okay, all right.
Yeah.
All right, I draw this for you, okay?
Okay.
So what is the relation between this L and wavelength?
L equals lambda.
It's lambda, okay?
Yeah.
Now, if you want to see there's a pattern, I just rewrite this one, not A, but lambda. So this L lambda, can you see? I put a 2 here because okay. I'm searching for the pattern, okay? After all, both physics and mathematics, you are looking for the pattern, okay?
Yeah.
So once you got it here, then we can summarize. So the formula is that the nth harmonic, is took the n here. I think in all eta, they have this formula for you, right?
Not sure.
Yeah, they didn't tell you, but this just, this also apply for the pipe. This pipe, right? If this for the pipe, the formula is the same. The formula is the same. Yeah.
Yeah.
Okay. So the standing wave, that's the formula. I think that is special case. Okay. And that is, I think that's enough. All right. Of course, they have several scenarios. One is open, another is closed, right?
Yeah.
I think this eta required by eta, but in this page, they're not required this formula. Okay.
Okay.
But another thing is interference. That's important. Okay. Interference. Okay. Interference is that if you have two sources, can you see S1, S2, and they have emit the wave. It's called a coherent wave. They join together at P, right? Their travel distance called path length. Can you see? So can we call the path length x1, x2? So that is the distance between the two sources. Can you see? There's two sources. So basically, the interference says that if the difference between these two paths is multiple of wavelengths n multiply lambda, they got bright. Can you see? They got maximum. They got maximum interference. However, if that is if this n multiply half,
plus,
yeah, that is not. Then you get a minimum. That is a summary of this interference. It's very much depending on how the difference of the path. Can you see?
Yeah.
So S1 and S2 represent the two coherent sources. Okay. Now, in the special case, we have to draw your attention. So in the special case, I think that is required by this test. So if you have a special case, you have can we start from double slit? Although they didn't ask you so far, but it's better to know this formula. You have double slit, right? So if there's a distance D, and then if you're looking for some place after this is queen, you are looking for this 0, this distance y, can you see that height is I, and this is theta. Then the formula is reduced to this formula, that is a d sine theta. I think you got this formula.
Yeah, that's on the syllabus.
Yeah. That's for the double slit, okay?
Yeah.
In other words, this is what is it called? This path difference. They use delta, all right?
Okay.
However, let's go to next page. However, you have to be careful. The condition for the single hole, okay, this single slit or single hole is different. Can you see? It's called a single slit or single hole. Or single hole, okay. Do you remember the camera? The single hole camera?
Yeah, there is.
Yes.
Reverse.
So in this case, can you remind you, the formula is the same. It's similar to the constructive. So that is something confusing, right? So for example, if this is a diagram, can we use a D for the diagram of this hole, right? And if you put a screen here, it's called this is screen. And you will see that at the center, they have brighter, at the center, they got the bright, at the center is bright. You see this intensity, okay?
Yeah.
And but if you go further, you will see the dark, can you see? So that is slightly different, can you see? Probably will draw this tension because in this one, in this case, the pattern for the interference is equal distance, can you see? I get the maximum here is equal distance, can you see? Can you follow me? So that is equal distance. But for the single, this is for the single slit, they only got brightness at the center, okay? Now, if you want to see 2D, because this, you will see this one. So basically, if you look to, so basically at the center, this is bright, can you see?
Yeah.
It's bright. And after that, you got the ring here, got a ring. Okay. And more, you got more, can you see?
Yeah.
That is a single hole, can you see that? Of course, if you want to make in the camera, if you want to use a single hole camera, then the D must be not too small, because this distance, can you see? This first maximum here, I just highlight this diagram. You see, that is the first darkness, can you see? This first darkness here, so this distance is Y is equal to, the formula is the same. So this formula is that when, if you use D here, so basically the condition, the formula is used is capital D, right? So there's a D sine, this is theta, okay? Can you see the theta? This is theta.
Yeah.
So sine theta is equal to lambda, all right? So this is strange because this is dark. Can you see this part is a dark? Can you see? Anyway, don't confuse with this formula with other formula. Okay, this is a single hole.
Okay, but how does that relate to Y?
The Y, yes. Then you have used this right angle triangle. Can you see?
Okay.
And you have also used a small angle approximation. So if this distance is L, they will tell you, they will give you the distance between the slip and the screen, right?
Yeah.
So obviously tan theta is exactly equal to Y divided by L. That's how they related to these two variable.
What's the relation between D and Y?
Again?
When the hole gets bigger, what would happen to Y?
Y will get increase. Y will increase. Can you see what is Y? So this particular point is Y. At the center, it is 0. Can you see?
Okay.
So
when D is very, very small, then Y will be very small.
Oh, yes.
Okay.
So in other words, if you reduce, I will see this equation now, relation now. At the moment, we haven't seen that relation because this is second formula. Then you have get formula with small angle approximation. They call the small angle. Do you use this approximation in before?
Oh, like one sine or something.
Yes, that's right. So when suppose these all became equal, can you sine theta were close to tan theta, you see? Or close to theta. That is called a small angle approximation.
Yeah.
Okay. So in that case, so can we modify the S? So that became D multiply under this approximation, D is equal to Y over L, equal to lambda. Can you see? Can you see my approximation method?
Yeah.
So that is why the L, so the lambda, so the D is so Y is equal to L lambda divided by D. Can you see that's
But
why?
they're inversely proportional.
It is inverse proportional. Yes, you can see
if
that.
D is smaller, Y will be bigger.
Oh, yes, yes. So that is why when you're making the whole single hole camera, do you remember single hole camera? On the one hand, yeah, go on.
So when like the theta is significant, D the increase in D will increase Y, but when theta is very small, increasing D will
no. If the hole is too large, there's no interference. So this phenomena is that this occur is when the D is approaching to lambda or even smaller than lambda, you see? Okay. So this is a condition for the interference occur.
Yeah.
Approach to or is smaller, okay? Of course, you see the visible light is very small, but I give you a question. So what is lambda for the red color? Can you give me the, in terms of the nanometer? What is the wavelength for red color?
I don't remember. 10 to the negative 5.
600 nanometer. Okay, this is probably something useful for you. For the violet, purple?
900?
No, shorter.
Oh.
200. Ah, be careful. Violet is shorter, you see.
Okay.
But the frequency is higher, you see. Frequency is higher. I think this is useful for you prepare the exam, all right? So if you do that well, we come to reciprocal function again, can you see?
Yeah.
That's why. So when you making a single hole camera, you have to be careful. That's why. So that is additional for the interference. Okay. Any other thing? No nuclear. We don't start nuclear. The probably we need to talk about this. The torque, right? This is something I mentioned at the beginning. No, they don't study. The Bohr model. But before that, can we talk about this issue? That is the torque, right? Yeah. So torque is by definition, tau is equal to the R. Have you said cross product?
Yes.
Yeah, that is by definition. Torque is related to the F by the R. And what is R? R is a distance from the center. For example, if you have object like the seesaw, okay, if you like seesaw. So that's how to apply this. Because it's very important to study the rotation. You see, if you want to study the rotation, and then you have to decide what is a torque acting on the object. For example, you have the beam here, you have the beam here. So if you apply the force, can we just apply the force here? If you apply the force here, and this is the center, so this is axis, this is the center of axis. They can rotate, can you see? Common sense tell you that the object will rotate, okay, in this direction, you agree?
Yeah.
So this is called axis. So this dot represent axis. This axis of rotation, rotation. So in this case, this is R. I just use this, how can we draw this R? R is a vector of this point of action, can you see?
Yeah.
The purple one by definition, that is called R, a vector. So this is R, this is F. Okay. Now, if you, so if the R here, and if you put the two vector here, they also satisfy the so-called right-hand rule. Did you use right-hand rule? So this is yeah. So basically, if this is F, you can see I use 3D. This is F. This is R. This is R, and the torque. The torque will be perpendicular to both. Can you see? That is the relation between three vectors. Is a force, and that is R. Okay. Now, if you have another force here, can you see another force on the other side? Can you see? So this is F1. This F1 is F2. Now, can you work out the force? Can you work out the torque? Like from the force 2?
Force.
Yeah.
Force up.
So torque 2, how about work out 2? Yeah. R is the same, right? R is the same in this case.
R is going to right?
Yeah, it's go other side, yeah, but direct, they change the direction. So this is, so R is from the center, from the axis.
So the torque will be pointed out of the page.
Yeah, out of page. So therefore, this torque, second torque is counteract with the first one. Can you see?
Yeah.
Now, so therefore, there's acceleration for this rotate, depending which is larger. So therefore, Newton's second law can be applied here. So this there's a, so this is a, if I write down here, this torque 1, okay, plus torque 2, were determined by that this time we have used the acceleration of angular momentum. So this is the theta second derivative. Have you used the second derivative, right?
Yeah.
Yeah. So that is another formula. Maybe we will discuss this formula. All right.
Okay.
So what is theta? So this angle, can we call this angle the theta? All right. So the theta, the first derivative of theta will give you the rotation. It's called the omega. So that is angular velocity, right?
Yeah.
Angular velocity. Angular velocity. Very, very important formula, velocity. And the second derivative, you can see, the second derivative of this one. So the d theta's second derivative or d omega first derivative will give you the acceleration or rotation. Can you see?
Angular acceleration.
Yeah, they sometimes they use beta for some in order to differentiate that. They call it angular acceleration. All right, we'll continue next time now. Okay. So the torque, we probably will take a few examples to digest this formula. Okay. So when you involve the rotation, okay, like the bicycle question, you have to consider the torque, not just the force. Make sense? Because yeah, go on.
When do you use it?
Oh, well, we have, for example, we have the challenge question. One of them, the bike is moving against the vertical wall. Remember?
Yeah.
The bike is against the wall, and his tire is attached with this wall. Can you see? So in this case, you cannot use Newton's law because the force is acting. You have to consider the torque. Okay. Make sense? Because this question cannot be solved by Newton's second law because you have found the torque, and you have considered that what is possible for this bike guy either go this way or this way about this axis, okay?
Okay.
So it's a different, it's slightly different from the force. Okay, we'll save that.
Okay.
You can prepare more formula or question we can discuss. Okay.
Yeah.
See you Wednesday.
Thank you.
Goodbye.
Thank you. See you.
See you.